It's Thursday, the 24th of February 2022, and welcome to the Water Action Platform. If you're new to this, where have you been? This is our 36th broadcast. If this was the British monarchy, and we work on the assumption that it all started in 1066 with the Battle of Hastings and the appointment of William the Conqueror as our first proper British king, then we have now made it 36 monarchs later to Queen Victoria. Next month, it will be 2 years since our first broadcast, and I hope you've enjoyed them as much as I have. Today, we have another wonderful programme which builds on last month's decentralised water theme to look at decentralised wastewater. We will hear about the Horizon 2020 funded programme called RUN4LIFE, which I think sets the benchmark for what decentralised wastewater could potentially achieve.
So, in one step, it's possible to achieve the treatment of the black water, the production of biogas, and the production of safe fertilizers thanks to the high temperatures.
And we have two excellent technology showcases. And the water sector specialist at the National Trust will share some of the challenges that he faces when managing water at iconic locations. And for our "And Finally" story, well, you probably remember being taught at school about the anomalous behaviour of water when you're... and today we have an update on that which will rock your world. If that wasn't enough, we will finish today with something that's a little special from the Hollywood great Bruce Lee. All of this is made possible due to our sponsors, and I thank them all. However, we start today with what will probably be the last vaccines and variants update from Joe Burgess. I'll share in a moment about what Joe will do next. Joe, rather unfortunately, has finally succumbed to COVID. Joe, we're thinking of you and hope you're feeling fine. Over to you.
Hi, Piers. Thanks for that. Yes, I'm okay at the moment. Regulars at the Water Action Platform will be fully aware of wastewater-based epidemiology and its role during the pandemic. WBE for SARS-CoV-2 started in March 2020, very early in the pandemic, even before widespread individual testing was available. WBE has also been heavily used during the Omicron Wave, which is helpful for a number of reasons. First, more and more people have started to use at-home testing. Because of this, cases aren't officially reported. Wastewater, on the other hand, captures more cases whenever people flush their toilets. Second, WBE worked as a fantastic warning system. In fact, it was one of the first surveillance systems to predict the infection uptick right here in Tshwane, Omicron's epicenter in South Africa. Before cases rose, detection of COVID-19 in wastewater was almost as high as it was with Delta. As early as November the 26th, we knew this meant one of two things. One, a rise in cases was coming and coming fast, or two, cases were so mild they were going undetected. Time told us this was a combination, but because of this system, South Africa was able to warn the world of what was coming. Third, WBE helped indicate when Omicron peaked. For example, officials in the Twin Cities in the USA accurately predicted the Omicron peak before it happened by monitoring wastewater. This is critically important when laboratories taking cases or samples from case numbers of patients are backlogged, and they were by several days. Fourth, wastewater can also be tested for the type of variant using genomic sequencing. So we could watch Delta and Omicron, for example, spread in close to real time. This is a huge advantage over sequencing among patients, which often sees delays in clinical samples and also small sample sizes. WBE can have sequencing results within 5 days to better help public health officials understand and predict what's going to happen next. Lastly, and maybe most importantly, is that public health and sewers are about people, not just numbers. A group of scientists in Louisville conducted a survey last August to assess surveillance awareness and acceptance among the public. They found that awareness of tracking the virus in sewers was very low, but most participants, regardless of their sex, their race, their ethnicity, strongly supported public disclosure of the results of monitoring. So there's no doubt that WBE continues to strengthen public health systems. It brings greater equity in a way that's anonymous, passive, bias-free, and acceptable to the public. and I really hope to see it grow as a tool in our box when we face the future. It's a critical tool in our toolbox. And what does this future hold? In order to know how this will end, we need to look at how other pandemics ended. First, let's recognise the last part of that sentence. Pandemics end. Every curve comes down. The vast majority of scientists think that an endemic state is the future of SARS-CoV-2, and I agree. However, there are lots of misconceptions about what endemic means, making it probably the most misused term of the pandemic, aside from herd immunity. Just because endemic contains end doesn't mean this is the end. It means steady state or static, no huge waves, no national crises, no calls for help from healthcare workers on the front lines. The journey to reach stasis is dependent on the virus, our population level policies, and our individual level decisions. It will depend on how we prepare and whether we do it wisely. Together, this will determine how many more people will die, how many more people have to get long COVID, how many mutations we'll face, how many vaccine doses we need, and most importantly, how we stay sane and united. I strongly believe we'll do this by riding the waves and using the tools we have. This will protect individuals and populations when transmission is high, and give us all a break when transmission is low. A group of epidemiologists, public health practitioners and doctors have worked together on a framework to reflect this line of thinking, and this is what they came to. I know it's tiny on your screen, but you will get a link and a full-size picture from peers. There are a few things in this framework to call out. So, individual level. This is for individual decision-making. In other words, it answers the question, what should I do today? Personally, I don't agree that we need individual level measures. They are far less effective than population level ones. But in our increasingly individualistic society, we need to give people evidence-based solutions to navigate the landscape that they find themselves in. Second, use of case numbers. This framework is anchored by cases. Much to my surprise, COVID-19 metrics largely held up during the Omicron wave. Test positivity rate was followed by case trends, which was followed by hospitalizations and deaths. But I suspect this will change with time. When cases and test positivity rates diverge, we will need to integrate another metric for behavior, like wastewater surveillance. Then vaccination rate. The vaccination rate of 85% of total population was included by Jetelina et al. Deliberately as a cut-off point for removing precautions regardless of case rates. Some countries like Denmark and Sweden are already removing all precautions. But we know that variants drive breakthrough infections. Triple vaccinated people who've still become infected with COVID-19 are 3 times more likely to have Omicron than they are to have Delta. Researchers in the US collected samples in December 2021, when about half of their COVID cases were Delta and half were Omicron, and they were able to show that any booster is still more effective than no booster. It halves the risk of Omicron by 50%. Then community level action. Even though Denmark, for example, has a high vaccination rate, they still have very high community transmission of Omicron. Removing all precautions with an above 85% vaccination rate will not protect the vulnerable or address the global problem, and this is why the community level action line in the framework is absolutely critical. Bottom line, we need a framework that accounts for an uncertain future. Maybe this was our last wave. Maybe the pan-coronavirus vaccine that I spoke about last month will send SARS-CoV-2 into the history books. Maybe one day we will achieve greater than 85% vaccination around the world. But in all likelihood, Omicron is not the last wave, so we should prepare to use the tools we have to reduce individual level and population level risk. My husband and I have COVID at the moment. Our son is still fighting long COVID. My family and I will be riding the waves, and I invite you to join us.
Joe, thanks for that. We wish you and your family well. Now, as I mentioned before, that will probably be the last vaccines and variants update, unless, of course, there are notable developments, in which case we will obviously report them. Now, I'm pleased to tell you that Jo will remain a regular Water Action Platform presenter, as she's taken on the role of head of Trial Reservoir. And from next month onwards, she will report here on how the various trials are progressing. You will no doubt recall that the Trial Reservoir is an initiative we launched in November just after COP26, which helps accelerate the adoption of technologies which will address the climate crisis. It is a pot of money which ISLE has given to the water sector, which can be used as an evergreen fund to support trials and demonstrations. It has the unique added twist that if a trial is successful, i.e. if it meets its predetermined success criteria, then the end user, be that a water utility or a commercial business, must make a meaningful commitment to adopt that technology. As you can see from this graphic, we've had over 70 applications with 3 trials right on the cusp of starting. From next month, we, or rather Joe, will report here on how those trials are progressing. Our mission is to share as widely as possible the learning as to how we can all address the climate crisis and achieve net zero. Now, the Trial Reservoir has received letters of support from a number of respected, august organisations, from the International Water Association to the Institute of Civil Engineers. But last week, rather incredibly, we were contacted by the World Economic Forum, and we will be presenting the Trial Reservoir initiative at Davos in May. We've been asked to share the Trial Reservoir initiative in the context of what great could look like if the water sector fully mobilised to address climate change. In particular, we've been asked to include examples of successful public-private partnerships and best practices that can be replicated and scaled across supply chains and economies, and also to help identify the potential bottlenecks and enablers. If you, dear viewer, want to contribute, please send me your examples and experiences. We will factor them into the white paper and the presentation which we will be making at Davos in May. We now come to another internationally acclaimed project, RUN4LIFE. In a moment, Dr. Nicolas Morales, head of R&D projects at Aqualia, will give a 3-minute mini lecture on this groundbreaking project. In the context of wastewater decentralization, RUN4LIFE sets the gold standard of what could potentially be achieved. So, without further ado, let's hear from Nico.
Hello, I'm Nicolas Morales, Project Manager in the Innovation and Technology Department of Aqualia. I'm going to talk about an experience in decentralized wastewater treatment for the recovery of resources, the ACE 2020 RUN4LIFE project, a European project that was coordinated by Aqualia. Usually, the conventional sanitation systems are based on linear and centralized approaches, where diluted and mixed streams are treated together. With that, resource recovery can be difficult. In RUN4LIFE, 15 partners from 7 countries in Europe have worked in the decentralized treatment of segregated streams, with the objective of improving the recovery rates of energy, water and nutrients, and we have demonstrated its advantages in 4 demonstration sites in 4 cities in Europe. In our case, the streams collected at the source were the black water, the Greek water and the organic waste from kitchen, but also other streams as yellow water from urine or rainwater could be treated in decentralized approaches, as one of the main advantages is that resource recovery processes can be tailored to specific local priorities in decentralized wastewater treatment systems. Anaerobic processes were the core for the recovery of energy from the organic matter, while nutrients recovery processes were applied to the liquid or solid effluents in order to recover the nitrogen, phosphorus or potassium. So some brief comments about the site. So here we have seen the demo in Ghent, where it treats the kitchen waste and black water in an USB reactor, recovers struvite and interchanges heat and water with a nearby industry. In addition, this development was based on a cooperative business model, where the owners of the houses participate in the whole system. In Helsingborg, the 3-pipe concept is applied to a renewable district, and toilet wastewater, organic kitchen waste and Greek water are separately collected and treated. The water kitchen waste sludge, the struvite and the ammonium sulfate produced in the local treatment plant are mixed together and sold as pellet fertilizers. In Vigo demo site, a decentralized treatment system was applied in an office building. Fertigation water, so clean water rich in nutrients and energy, are recovered from the black water using the membrane reactor for an anaerobic nutrient and energy recovery process. And reclaimed water is also obtained from the treatment of the creek water and used for toilet flushing, also using a membrane reactor. Finally, in SNIC, the ultra-low flash vacuum toilets produce highly concentrated black water that is treated in an hyperthermophilic USB reactor. So, in one step, it's possible to achieve the treatment of the black water, the production of biogas, and the production of safe fertilizers thanks to the high temperatures. The decentralized concept is especially attractive when centralized systems don't exist. As an example, when we have new buildings, new developments, or new cities in developing countries, or in rural or isolated areas, when the system sewerage in the city is old or leaky and its replacement or upgrading is too costly, or when the existing wastewater treatment plants in the cities are overloaded. But there are also some barriers to implementation, especially when products are recovered, as the legal restrictions or the end of waste classifications, but also the social acceptance of the products or the limitations in the market can be an issue.
Thank you, Nicolas. Now, continuing the theme of decentralized wastewater, we now have two short technology showcases for you. The first is from 4Earth from Ohio in the United States. 4Earth use modified shipping containers to build plug-and-play decentralized water and wastewater treatment systems, which can achieve high contaminant removal and low process complexity. 4Earth's mission is to use decentralized solutions to bring sustainable, data-driven and user-friendly technologies to the markets to address the global water crisis. Now that is already a great mission, but I love the fact that they also want to incorporate modern design and art into their technology to help further enhance the culture of the water industry. Here is Janazeb Khan, founder and chief executive, to share some more.
Since we build our entire treatment plant inside of a modified shipping container, we can build our plant in a controlled factory setting, ship it off to a project site, and from there it's plug-and-play water treatment. Okay, the advanced membrane process, there's a lot to unpack here, but I'll keep it very brief. Our goal here is to reduce complexity in terms of how the membranes operate, in terms of what materials are used, etc. And one thing is to reduce the dependence on chemicals in drinking water treatment. Because we know a very specific example, such as disinfection byproducts, you're using oxidants and you're solving a great problem, but then you're creating other problems known as THMs, HAAs. So we have to step back and see how can we remove things out of the water without adding more things into it. In water treatment in general, we always focus on functionality, which is great. But we are human beings at the end of the day, and we love art, we love design, we love aesthetics. We love how something feels when you use it, when you touch it, when you look at it. So we like to bring this contemporary design into our product, as well as feature local artists in each project. So a community feels like this product belongs to them, and it's just not a box that came in to their community. As we know, conventional water treatment is a 5 to 8 step process, as shown in this diagram. And during that process, after they backwash their filters, they generate waste known as spent filter backwash water. Now, this waste conventionally is either sent back to the head of the plant to get retreated, or it's discharged to the sewer stream. So we use the first principles approach, basically saying this water has already been coagulated and oxidized. So we just need a small enough physical barrier to remove these contaminants and recover clean drinking water. So we developed our Catalyst X method. So basically we take this water directly into our system. We're able to produce clean drinking water in one step, and we can send it safely to the post-flash mix for it to get disinfected and distributed to the customers. We found that we can treat spent filter backwash water in less than half the cost of conventional treatment, less than half the steps of conventional treatment, and 5 times less the footprint in conventional treatment using our system. Our goal with the Catalyst X and Catalyst Mini is to provide a faster, easier to use, and more sustainable solution for drinking water treatment on both existing infrastructure as well as small communities and new development.
Thank you, Khan. Now, 4Earth has successfully piloted systems all around the world, in particular in Atlanta, Georgia. Our second tech showcase today is from Hydraloop, based in the water campus at Leeuwarden in the Netherlands, and also at the Global Water Center in Milwaukee. Hydraloop manufactures domestic grey water recycling systems without using a filter, membrane or chemicals. Their systems are capable of recycling 45% of mains water, thereby reducing sewage load and saving energy. Hydraloop has systems that are designed for domestic applications as well as scalable units for commercial properties. Here is Sabine Stuyver, Chief Marketing Officer and co-founder, to share a bit more.
We are the creators and producers of smart, innovative, game-changing, decentral water recycling units. We empower people and organizations with smart and affordable water recycling products so that as of today, they can make impact and contribute to one of the greatest challenges of mankind, drastically reducing the use of water.
The processor treatment tank is in the middle behind the stainless steel front plate. A patented combination of 6 treatment technologies is what we use to clean the water. Now, water enters the Hydraloop system from the top via a 40mm connection. The first treatment we use is sedimentation, so sediment is collected at the bottom of the processor tank and wasted automatically to the sewer. All floating dirt, like soap and hair, is trapped and collected in the middle tank and thrown away automatically via the skimmer to the sewer. And then we inject millions of air bubbles and we have dissolved air flotation. We have soap in the water and we use this. It's called foam fractionation. So soap, shampoo, hair conditioner, solids and organic matter are actually lifted out of the water and skimmed off by the skimmer and wasted automatically to the sewer. In the outer tank, we have an MBBR, and this is a biological treatment by aerobic bioreactor in the outside upper tank. The final step is the UV disinfection, and we take the water from the upper tank, it is transferred to the lower tank, passing a UV light. Now in the lower tank, stored water will pass the UV light every 4 hours again and is re-disinfected. Below the processor tank, behind the stainless steel front plate, is the distribution center. Hydraloop uses no filters or membranes, so the system cannot clog. The system is self-cleaning by timed rinsing and removes waste, sediment and sludge to the sewer all automatically. The overflow and the waste output leave the system via a 40mm outflow. And the mains water backup, which can also be a rainwater, but it is a backup system, is connected via an air gap according to EN 13077 and is certified by Kiva.
Hydraloop was only launched in the last few years and has already received multiple awards, including Best of Innovation, Best Startup and Best Sustainable Product. It is definitely a technology to watch. We now come to our sector expert section, and this week we hear from Mark Roberts, the National Water Specialist at the National Trust, based here in the UK. I spoke with Mark earlier this week.
I'm here with Mark Roberts from the National Trust. It's wonderful to be with you here today, Mark. For those people who are not based in the UK, can you tell me who the National Trust is?
Great. Okay. Thanks, Piers, for the invite. So National Trust, we've celebrated our 125th birthday a couple of years ago. So we're an organisation that was set up 1895, and we're there really to introduce people to nature and beauty and history. And we're to look after the nation's coastline, historic sites, and the countryside. And provide access for people really as well to those things.
I'm a proud member of the National Trust. Now I understand you have you've got some international links. What can you tell me about those?
Yes. So National Trust for Northern Ireland and England and Wales are part of what's called INTO, which is the International National Trust Organisations. And so we have sister organisations all over the world. So it's great to meet up with them, to share information and knowledge. So it's a great organisation to be part of. Still waiting for my invite to the Bali conference as well. So hopefully that might come soon.
Maybe there's somewhere in Bali saying, I want the invite to Birmingham, UK. You never know.
I can do that. That's fine.
Right. Tell me, what's your role?
So my role for National Trust is on everything from water supplies, wastewater treatment systems, flood risk, sustainable drainage, reservoirs. So anything really with water on our sites.
Excellent. Well, today's broadcast is around decentralized wastewater. We did one on drinking water last month. And tell me, why does the National Trust need to worry about looking after water and wastewater treatment plants? Why don't you just rely upon the local water company?
Well, you know, we do have connections to mains water and sewage. We've got about 1,200 connections across the country. But obviously, our sites are often very rural and very difficult places to get mains supplies to. And so in order to be able to ensure that we don't damage the environment when we attract visitors there, we need to manage water carefully, and we need to treat sewage very carefully as well. So we've got over 3,000 sewage treatment systems across the country, each one sort of an individual entity. We've got 500.
Everything from sort of car parks on national parks through to stately homes in the middle of nowhere.
Absolutely, yes. So we have sort of countryside properties, sort of Snowdonia and the Peak District and the Lake District, all the way through to mansion properties. So yeah, it's very varied.
Mansion properties, I like that. I want a mansion property one day. All right, tell me, what are the sorts of problems that you experience with running this network of decentralized assets?
As you can imagine, this, you know, it's very varied. A number of problems crop up. I think generally I've got to focus one on a more sort of philosophical point, which is to try and communicate the value of water to properties. So the whole piece around water efficiency, why we should reduce our consumption so that we leave more water in landscapes so that it can be more resilient for climate change. That story is something that we need to develop and get better at telling. Specifically for us, we're coping with sort of the new stories around nutrient neutrality and phosphates in particular in our rivers, and treating for phosphate through sewage treatment is difficult. I think municipal systems are developing new ways of doing that. Small scale off-grid systems are not being served by that same technology at the moment, and so we're trying to work with various different people to develop a solution which is one, doesn't need 24-hour surveillance, doesn't need a chemical engineer on site all the time, but also is sustainable. So you don't have a waste product at the end, or we can reuse a waste product once we've removed the phosphate. So that's an area which we're looking into doing more work at the moment.
Excellent. And obviously we've spoken in the past about the Trial Reservoir, and I assume if anyone's watching this who has an appropriate solution and we could provide funding, you could perhaps provide a site, and we might be able to find a happy resolution to that problem. If you had a magic wand and could solve a problem, what's the problem that you'd try and solve?
That's a good question. I think really for me is to go back into valuing the landscapes that are around us, to understand really the job that they do for us in provision of water in particular, but many other things about well-being and sort of all those things around mental health as well. And, you know, if we value it enough, then we're willing to change some things in our own lifestyle to make sure that the next generation can enjoy those things as much as we have. I think that's really, really important. And if I could do that, I really would.
Well, brilliant. The National Trust is doing a wonderful job, and I'm a huge fan. Mark, thank you so much for your time today. It's been a pleasure speaking with you.
Great. Thanks, Piers.
For those who are interested, here are some links to some of the projects that the National Trust is doing, in particular to address climate change. And finally, You no doubt recall being taught at school about the anomalous behaviour of water, the fact that, unlike every other liquid on Earth, it doesn't get denser as it gets colder, but rather it is most dense at 4 degrees C. This is why ice floats and doesn't sink. Without this feature, arguably life could not exist. Everything in the oceans would die when it got very cold. Well, today's and finally story builds on this. Chemists have been thinking for some time that water should not be viewed as one liquid, but rather as two distinct liquid phases that coexist in a mixture. The exciting news today is that physicists might have made the first direct observation of this transformation between the two states. Here is a link to a paper by Suzuki from the National Institute of Materials Science in Japan. In it, they reported signs of a liquid-liquid transition, ending in a critical point where the two liquid states become indistinguishable in an emulsified, supercooled solution. Suzuki pressurized and then depressurized emulsified solutions and watched what happened. He saw a sharp increase in density as the pressure was increased, the red line here, and a sharp drop in density at a somewhat lower pressure on the decompression, the blue line. If water was indeed a single liquid phase, then the red line and the blue lines should be in exactly the same place. They aren't. So this graph demonstrates a reversible liquid-liquid transition, i.e. two types of liquid water. Understanding how super cold water solutions behave could have implications for biology and cryopreservation, where damage to biological tissues by ice crystals has to be avoided. It might also have applications on those water-rich states that might exist in the atmosphere of the gas giants in our solar system and beyond. Now, before we finish, I have one last thing to share with you, and it is this 30-second clip from Bruce Lee speaking in 1971 with his famous "Be like water" quote. You've probably heard it before, but what I'd like you to do now is listen for the last few words. We've dubbed them using the voice of someone who's very notable in the water sector. If you can work out who it is, well done, let me know, because next month we're going to do a very special follow-up.
Be formless, shapeless, like water. Now you put water into a cup, it becomes the cup. You put water into a bottle, it becomes the bottle. You put it in a teapot, it becomes the teapot. Now water can flow or it can crash.
Be water, my friend.
Did you get who it was? With that, we come to the end of this week's broadcast. Thank you to our sponsors, and I look forward to seeing you all again next month. The next broadcast will be on Thursday, the 24th of March, as it happens 2 days after World Water Day. Our theme next time will be groundwater. Keep asking questions, keep sharing, and keep safe.